So now that you have the top portion of your notes for student task number 2 completed, we're going to utilize these transformation form equations to actually write equations for the warm-up questions. So these are the same 3 graphs that you had in your warm-up. In question, the first question with the parabolas, you should have identified that to get from the red to the black, you are going to move to the left 2 units, 1, 2, and down 3, 1, 2, 3. So the shape of this graph did not change. The shape is the same. Anytime we change the shape, that's going to be a stretch or a compression. If we're just moving the graph side to side, up and down, or reflecting it, then that involves a translation or obviously a reflection. But the only way that we're going to change the shape is by actually stretching or compressing it. Okay, so we said left, oops, let's not write in yellow. Left 2 units and down 3 units. Okay, so once again, we are working with the quadratic. So the specific transformation form is here. So for each of these, I just went through and replaced the B and C, or placed the B and C within the function, and then the A and the D outside the function. Okay, if we need to move left and down, that tells me that we're looking up here at our C value. So I should have an X plus a number to move it left. And then down, we should have a minus D down there at the end. Okay, so this function you're going to actually write as f of x or y equals x plus 2 squared minus 3. So our C value right here is a negative 2. Remember, it's the opposite within that function. Okay, it's inside the function because that's a horizontal shifter. And then we've got right here D equals negative 3. So this graph, this equation right here would give the graph of the solid line for this parabola. Second question, I noticed that the steepness of the line in both the dotted and the solid are the same. So once again, our shape did not change, but we do have 3 transformations. Okay, I can see that the vertex went to the right 1 and down 2. So we went right 1, down 2. And then I also see that it went from pointing up to pointing down. So that's what we call a vertical reflection, or reflection across the x-axis. Okay, and we achieve that reflection by doing a negative A. Down 2 is going to be a negative 2 for our D value. Right 1 is going to be a positive 1 for our C value, but it's going to be written as an x plus C. So looking at our absolute value function right here, the A value, or the negative, is going to be out front of absolute value. Technically, you could write a negative 1, but just a negative will suffice. I don't have a B value here. Then we have x plus 1 for our C value. You don't have to put that in parentheses inside the absolute value unless you have an actual B value. And then out here we have a minus 2. Okay, finally, we've got a square root function over here. So that matches to that square root right above it. Okay, we can see that the vertex was moved just up 2. And then it's been reflected across the y-axis, or a horizontal reflection. So that is going to be achieved with a negative B value. Up 2 is going to be D equals 2. So if we write this function, we've got f of x equals square root of negative x And then on the outside, plus 2. So the negative represents in front of the x being multiplied. Whoops. Here we go. This b value. Okay, once again, it could be a -1. You don't need the parentheses because there's not anything being added or subtracted to the x. Wouldn't be wrong if you put them, but minimum, you just need the square root of -x with a plus 2 on the outside. Okay, so question 2 through 5, I'm going to have you pause and work on your own, and then you can, after 10 minutes, watch the next video, see how you did